Well, hello everybody. What I need to do with you today is I need to cover section 2-5, which is over logarithms. Now, it's been a while since you've seen logarithms. In FST, we did not cover logarithms, so the last time you would have seen them would have been your Advanced Algebra 2 days. So I'll touch on them, I'll explain to you what they are, and I'll show you how they're used, and then hopefully a lot of this will come back to your memory. So if you would come right over to your first example, 4 to the x equals 64. Now I picked this one because you've already seen it. One, you could look at it and know what the answer is. You can look at it and know the answer is 3. We also did this one with what we called the change of base formula last class. So I could think of this as 4 to the x equals 4 to the third, so therefore x equal 3. Now, another way to solve this is with the use of logarithms. So what I'm going to do is I'm going to take the log of both sides. So I've got log of 4 to the x equal log of 64. So I took the log of both sides. Now we'll review rules of logarithms as we go today, but one of the many rules of logarithms is your exponent can come down front. So I've got x log 4 equal log of 64. Now to solve this for x, I'm going to have log 64 divided by log of 4. Now in your calculator, I won't bring my calculator up very much, but I'm going to go log 64, close that off, divided by log of 4. Now that'll be how you'll type this one in. And you should get an answer of 3. Now, my number 2, you couldn't do it as a change of base because you cannot write 100 as a change of base of 3. So I'm going to log both sides. So I've got log of 3 to the x equal 100. My exponent can come down in front. So I've got x log 3 equal log of 100. To solve this thing for x, I've got log of 100 over log of 3. Now while I'm here, you know what the log of 100 is. Believe it or not, there's a 10 hiding right there when there's nothing there. So this asks the question, 10 to what power gives you 100? So that would be 2. Not that it matters in this case. You can run this through your calculator and get about 4.19. My number 3 then, my exponent is the unknown, so I can take the log of both sides and bring down that exponent. So I've got x log 11 equal log of 1,000. Let's divide both sides by log of 11. So I've got x log of 1,000 over log of 11. If you run that through your calculator, we're going to get x to be about 2.88. What we'll normally do, guys, on this is round to the nearest hundredth. Now, number 4 is the same steps, the same principle. I'm going to log both sides, but that 3x plus 2 is going to come down front. So I've got 3x plus 2 log of 6 equal log of 412. Now to solve this, I need to start getting the x by itself. So I'm going to divide both sides by log of 6. So I've got 3x plus 2 equal log of 412 over log of 6. Now I'm just going to run all of this through my calculator at once. So I'm going to have log of 412 divided by log of 6 equal to 3x plus 2. My next step, I'm going to subtract away 2. Whatever that answer is, I'm going to divide it by 3. Now you may pause the video here and make sure you can run that through your calculator. If you run that through your calculator correctly, you should get approximately 0.45. So guys, I just wanted to hit some logarithms just to show you how they're used to solve. Now I'll start talking properties of logarithms. So up top here I've got, and on your sheet I've got, the inverse of y equal a to the x. So the inverse of an exponential function can be written as log to the base a of y equal x. That's hard for me to remember, so I usually remember it more like this. I say to myself, log to the base, the exponent's over here, the answer is here. That way I can remember it goes base, exponent, equal the answer. Now if you see a few of them, it's going to make a lot of sense to you. So I'd like to write 5 cubed equal 125. I would like to write that as a logarithmic statement. So it's going to look like this. I'm going to have log to the base 5 of 125 equal 3. So that means 5 to the third equal 125. My next one, 4 cubed equals 64. That could be written as log to the base 4 of 64 equal 3, because 4 to the third is 64. Negatives, no problems. This becomes log to the base 8 of 1/64 is negative 2. So as an exponential, 8 to the negative second is 1/64. Now I've slid an e in here just so I can mention the natural log, because the natural log properties are the same. So my base happens to be an e. When that happens, I'm going to say that the natural log of base e of 738 is 2. Now normally, whenever you're talking about the natural log, you will not see the e as the base. So really, it would be written like this. The natural log of 7.38 is 2, approximately 2. Let me change that real fast. Now, of course, I'm going to go backwards now. I'm going to give you an exponential. I'm going to give you a logarithm, and I'm going to ask you to write it as an exponential. Well, if you can remember base, exponent, answer, you've got it whipped. So in this case, 5 to the third equal 125. And then you got it. On my next one, I've got the square root of 3 to the 8th is 81. My number 10, 16 to the 1/2 is 4. So continuing on, I want you to think about these in your head, but I'll also show you how to run it through your calculator. Log to the base 3 of 27 asks this question. 3 to the what power is 27. 3 to the what power is 27. Well, if you just think about that one, we know it's going to be 3. Now, to solve this as a logarithm, I want to show you what's called the change of base. If I write this as an exponential, 3 to the x equal 27, and take the log of both sides, I get this. I get x log of 3 equal 27. And my pen's doing something weird. I'm going to divide both sides by the log of 3. So I've got log of 27 over the log of 3. And if you run that through your calculator, you'll get 3. Now, shortcut to you. Whenever it's written like this, log base 3 of 27, in your calculator, if you'll go log 27 over log of 3, you'll get your answer. So on my number 12 here, 2 to some power is 100. 2 to some power is 100. If you run this part through your calculator, you'd have log of 100 divided by log of 2. If you run that through your calculator, you should get about 6.64. That's called the change of base formula. So what I've done in my next little section here, guys, is I just mixed them up. To solve some of these, we need to write them as an exponential. Some of them will just take the log of both sides. Some of them we're just going to run straight through our calculator. So we'll attack them and go. If I get going too fast for you, please feel free to pause your video. So my next one here, log of base A of 81 equals 4. A lot of times what we'll do is we'll write this as an exponential first. So I'm going to write this as a to the 4th equal 81. Now this is like one we did the other day. My unknown is not an exponent. So to solve this for a, I'm going to raise both sides to the 1/4 power. So I've got a is 81 to the 1/4. And if you run that through your calculator, we're going to get a must be 3. Now, normally it would be positive and negative 3, but you can't have a negative base. You can't have a negative base there. So just take the positive part. Here's another one similar to it. Log the base n of 625 is 4. I'm going to think of this as n to the 4th equals 625. I can't use logarithms to solve it because my unknown is not an exponent. So I'm going to raise both sides to the 1/4 power. And if you do that, you're going to get n to be 5. Here goes my number 15. I got log base A of 136. That 136 should be up a little bit, equal negative 2. So it's going to look like this. A to the negative 2nd equal 136. A to the negative 2nd equal 136. Well, to solve this thing for A, I've got 136 to the negative 1/2 power. Now, to solve this, I'm going to think of this as 36 to the 1/2 power. That way I could get rid of that negative exponent. And it looks like my A is going to be 6. Okay, if you look now at number 16, log the base 4 of 8 equal x. Guys, this is one of those that we can type right into our calculator. I'm going to type in log of 8 over log of 4. A worst case scenario, you go 4 to the x equal 8. You log both sides, so you got x log 4 equal log of 8. And then you divide both sides by log of 4 to get x by itself. So same thing. And if you run that through, you're going to get 1/2 in this case, so that's going to come out to be 3/2. 17 is another one. 25 to some power is going to equal 100. So what we're going to type in, log of 100 over log of 25. Get n to be about 1.43. And then our number 18, log of the base 4 of a equal 3. I need to think of this as an exponential, so I got 4 to the 3rd equals a. So a must be 64. Here's my number 19. Log of the base 4 of the quantity x minus 1 is equal to 2. We'll write this as an exponent first. So I'm going to think of this as base exponent equal the answer. So I've got 4 squared equal x minus 1. We've got 16 equal x minus 1. Looks like x must be 17. Here's my number 20. Log to the base 17 of a equals 0. If we write this as an exponential, I've got 17 to the 0 equal a. So a must be 1. Anything to the 0 is 1. Now I slipped number 20 in there because of the e. Whenever the e shows up, we don't think about the logarithm, but the natural logarithm. So to solve this one, I'm going to take the natural log of both sides, and I'm going to bring that exponent down. So I've got 3x plus 1 times the natural log of e equal the natural log of 100. Now, the natural log of e is 1 because there's an e hiding right there, and this says e to the first equals e. So the natural log cancels each other out. So now I'm at 3x plus 1 equal the natural log of 100. Now let's solve this. So I'm going to subtract 1 from the natural log of 100 and then divide by 3. And then if you run that through your calculator, you should get about 1.2. So like I said, feel free to pause the video, use your calculator, or you can take my word for it. Now, believe it or not, we're getting close to having quite a few of these with. Now, more properties of logarithms. Remember, a logarithm is an inverse of an exponential. So, if you think about this, if we had a to the m times a to the n, and I ask you what to do, you would tell me to add those exponents. That's the same thing if we're dealing with a logarithm. If I have a log of a times b, I can expand that using addition. So I got log of a plus the log of b. If I had a to the m over a to the n, you would tell me to subtract those exponents. Well, that's the same principle as a logarithm. The logarithm of a over b can be written as the log of a minus the log of b. And then one rule that we've already used a couple of times, if you have an exponent, log of x to the n, you can bring that exponent down and just get n times the log of x. So there's some rules there for you. They tie into our exponential rules. Same base, add your powers. Same base, but division statement, subtract your powers. Power, we can bring that down. So, here goes my 21 on. I've got log of ab squared. Now, after you see a couple of these, you'll skip some steps, but I won't skip any on this video. I can think of this as log of a plus log of b squared. Multiplication, I can split it up using addition. Now, I have an exponent right there which can come down front. So here's my ending answer. Log of a plus 2 log of b. 22. I'll do it in steps, but after you do a couple, you'll do it in one swipe. I'm going to think of this as log of a plus log of b squared plus log of c to the 1/2. Now my exponents can come down front. So I've got log of a plus 2 log of b plus 1/2 log of c. 24. I've got the log of the quantity a times b to the 4th. I can do a couple of things to this. I could think of this as log of a to the 4th b to the 4th and then expand it. So it would look like this. Log of a to the 4th. As my PowerPoint jumps a little bit, plus log of b to the 4th. If we bring our exponents down, I've got 4 log of a plus 4 log of by 24. I've got log of A plus log of B squared. Now since I've got division, I can go minus log of C. Then to bring it home, log of A plus 2 log of B minus log of C. This becomes an important concept when I teach you the derivative of tougher logarithms. And then my number 25, there's a division statement. So I'm going to think of this as log of x to the 1/2 over y. Well, if we skip a step, we've got 1/2 log of x minus the log of y. So there we are expanding some logarithms. There we are expanding some logarithms. Now, this little group, we're going to put the logarithms together. We're going to write them as a single logarithm. So we're going to undo what we just did right there. So here goes. My number 26, I got log base A of x plus log base A of y plus log base A of z. Well, I can combine this to a single logarithm by thinking of it as log to the base A of x times y times z. The addition meant multiplication. My number 27, I can think of this as log to the base A if my pen will write. There we go. Now, I've got x times 4 log base A of y. I can think of that as y to the 4th. Minus means division, z to the 3rd. So if I clean that up just a little bit for you, I got log to the base A of x, y to the 4th over z cubed. Here goes my number 28. 3 log base b of 2y plus 5 minus 1/2 log base b of y plus 3. As a single logarithm, it's going to look like this. Log to the base b. Well, if you look at this part, that 3 must have been an exponent at some point. So I've got 2y plus 5 to the 3rd. The minus tells me division's coming up. Y plus 3 to the 1/2, or square rooted. So there it is as a single logarithm. A little bit more if you need there. And then I've got a couple where I'm going to show you how we solve logarithmic equations. So here's my number 29. Solve log to the base 3 of x plus 2 plus log to the base 3 of 2x minus 3 equal 5. Well, the key thing, guys, we need to write this as a single logarithm. And since it's added together, at one point it must have been multiplication. So this becomes log to the base 3 of x plus 2 times 2x minus 3 equal 5. I just put it in the brackets because I saw more coming. Now guys, if I write this as an exponential, this becomes 3 to the 5th equals x plus 2 times 2x minus 3. If I start solving this, I'm going to have 3 to the 5th, 243, equal, we got to FOIL this part out, 2x squared minus 3x plus 4x minus 6. If I keep going, I've got 2x squared plus x minus 249. Now we still have to solve this thing. We still get to solve this thing. So yeah, I'm not going to try to factor that. I'm going to go straight to the quadratic formula. So I've got the opposite of b plus or minus the square root of b squared minus 4 times a times c, all over twice my a value, which would be 4. And if you take a second and run that through, guys, you're going to get that x is approximately 10.91 and approximately negative 11.4. Now, we have to be careful here. I need to make sure that I can use both of these numbers, because you can't take the logarithm of a negative number. So if I plug in negative 11.4 right here, I'm going to try to take log to the base 3 of some negative number. And that can't happen, because it would mean 3 to some power equals negative 9.4. So even though it looks like there's two solutions, there's my only solution. So this one's an extraneous solution. So be careful of those. Here goes another one very similar to it, but easier. I've got log base 3 of x plus 2 minus log base 3 of 2x minus 3 equal 5. So very, very similar to the problem above it, but where number 29 was an addition, 30 is a subtraction. So when I write this as a single logarithm, I got log to the base 3 of x plus 2 over 2x minus 3 equal 5. If I write this as an exponential, I've got 3 to the 5th equal x plus 2 over 2x minus 3. If I start solving this, I've got 243 equal x plus 2 over 2x minus 3. If I cross multiply, I'm going to get 486x minus 729 equal x plus 2. Oh, I'm going to subtract x over here and get 485x. I'm going to add 729 to the other side and get 731. So it looks like my x value is going to be 731 over 485. The key thing there, though, is I wrote it as that. And then it looks like I've got 2 or 3 left. We're kind of to the downhill slide finally. Find the number of years it will take for an investment to double given 5% interest compounded annually. So it doesn't matter what principal you pick. I'm going to pick 1. And then by the time it doubles, that would be a 2. It doesn't matter if you pick 1 and 2, 100 and 200, 1,000 and 2,000. That part doesn't matter. Now my equation is going to look like this. 2 equal 1, 1 plus, they told me my interest rate was 5%, so I got 0.05, over the number of compoundings, which is annual, which is 1, raised to the t. Now if we start solving this, I've got 2 equal 1 times 1.05 to the t. Now to solve this, we can take the log of both sides or the natural log of both sides. It really doesn't matter. I'm going to use the natural log in this case. I'm going to natural log both sides. So I've got the natural log of 2 equal t times the natural log of 1.05. If I solve this thing for t, I've got the natural log of 1.05 over the natural log of 2. And if you run that through your calculator, you should get about 14.2 years. Now guys, you're going to get the same answer if you would have used logs instead of natural logs, as long as you use the same thing to both sides. So there's my number 31. 32 and 33 are, you see these in business books. They're kind of cool, so they're kind of easy. It says the rule of 70 says that if your interest rate is between 0.001 to 0.05, the value of 70 over 100R gives a good approximation of T. Find the value of T for problem 31. So back to 31. Find the number of years it will take for any investment to double at 5%. Well, remember our answer was 14.2. So if I set this up, I've got 70 over 100 times 0.05, which means I have 70 over 5, which gives me 14 years. That's called the rule of 70. Now there's a similar rule for the rule of 72. The rule of 72 says that if your interest rate is between 5 and 12%, the value of 72 over 100R gives you a good approximation of how long it takes your time to double. So let's look at that one. Since 5% is in there, I'd have 72 over 100 times 0.05. Run that through your calculator. You're going to get 14.4 years. So we did the same problem 3 times. I used the book's rule of 72 and 70, got 14.4 and 14. We did it by hand and got 14.2. So, now I do have a book assignment written down at the bottom of your page, but your assignment is on Math Excel. So good luck. Come in and see me if you have any problems.